Hi, welcome everybody. And today we're gonna do a tutorial for homework 6. So as you can see in homework 6, what we have to do is design a trash can in which we apply certain inputs to the crank, and we want the output to be at a certain angles. So we want to design a mechanism that the 2 points attached to the floor are in the 0, 0 position and the 21, 37 position. And then we want that when this is at the position 160, the other is at 180. When the input is at 165, the other is at 155, and so on. So as you have seen in class, there is the app MechGen FG from the Apple Store. But the problem is that not all of us have access to an iPhone or an iPad, especially during quarantine. So you can either do it using the app. You can also ask for the dimensions. For instance, I have asked Professor for these dimensions. You can ask one of your TKs or anybody else for these dimensions. Or, which is very, very interesting, you can also use Mathematica code. So for designing the trash can, we will use these angles. However, I will also teach you how to use the Mathematica code to design this mechanism. It's really similar than the MechGen FG, but in that case, it's using the computer, which has already installed Mathematica, which is a really cool program. So let's open the Mathematica code that I'm talking about, which is this one. Don't get scared because there is a lot of things written there, but at the end, it's just like the MechGen FG app, just that here you can see all the code. You only have to care about this. So these are the input position in degrees. Sorry, these ones. These are the output positions, and this is the position of the input and the position of the output. So we just have to change this in our exercise, if I remember correctly. Okay, so 160, 165, 170, and so on. Here, 55, 30, 5, 80, right? Yes. Okay. And the positions of the origin of the input crank, it's at 0, 0, and the output must be at 21, 37. Okay, so we've done it. Now, the only thing we have to do is we don't have to care about the code. We just go here, select this, and while pressing the Shift key, we press Enter, and the code will execute. You will see that everything will become in black, and will come back to normal as it is executed. So I press Shift, Enter, and the code has been executed. We go down, and we just say compute linkages. Okay, and different solutions will be generated. For instance, this looks a pretty good solution, but we also have others. For instance, in this case, much different solution. Maybe it's not the one that we want if we want to design a trash can, but in other cases it could work. All these solutions work. Of course, I think I have not designed the code, so I am unsure. But I think that the first solution it's usually the one that approaches better the angles that you decide. But I might be wrong, so don't put a lot of trust in me in that. Just pick the one that you think that will be better for a trash can. But if you don't want to use Mathematica, remember, you can ask. You can either use the iPhone, the Apple Store app, or you can ask some of the responsibles for the subject for the input and output anglers that we can use to do a proper trash can. So in our case, we will use these ones. Okay. Perfect. So we're going to start with the SolidWorks. So we have to design several parts. This will be the folder in which I will work. And regarding the templates from the subject that we usually use to build the SolidWorks, we only need the axle screw and the bushing. Everything else we will design ourselves. It will be just, I think, 4 parts, so it won't be that much. But some of them are a little bit tricky. So let's get started. The first thing we're going to design is the can itself. So we go here, we press File, New, and let's start a new part. Let's going to save it first before starting anything. Okay. So base. Okay. Let's remember to work in inches. And let's start. So we will work from a top view because we're going to design the can and we're going to extrude it. So we are going to design the base first. So sketch. Let's design a circle. So you can design it however you want. In my case, I have seen that this is 21. So maybe if we have to put a number, maybe a distance of 30 could work. So let's do it. Let's go back to SolidWorks. And let's ask it to be 30. Perfect. And now let's extrude it. So remember that this distance must be 37. But if we approach, there is a little space that it's not considered in this 37. So I will write 38 in that case. So I will come here and extrude 38 inches. And that will be the base we will be working on. So now what we're going to do is design the space for the first bar to come. So we need like a tunnel inside here. So we're going to design it. So we're going to work with the base. So we'll open a sketch here. We will work normal to this sketch. Okay. And now what I'm going to do, first of all, is create a center line. Perfect. I am going to create a line that goes from here to the other side, and that has to be horizontal. Perfect. Now I will set this line at a distance okay. So we will use bushings, right? Okay. So in this tunnel, the first the pedal is going to be into this tunnel, right? Okay, but we will be using bushings. So if we consider, for instance, distance of the of the pedal of 5 inches, for instance, it's pretty big, but let's just consider that because the trash can is pretty big also. So if we consider a 5-inch pedal, then we will need to take into account also the thickness of the bushings. I have done this design previously, so I can tell you that we will need 6 bushings between here and here. You can just believe me, or if not, you can try. And then when you see that you need more space, just redesign it. So what I'm gonna do now is open the bushing. Okay. And we will need 6 times this distance here. So we go to evaluate, measure from here to here. Okay, there are these inches, so we copy them. Now we go back here, and now we can smart dimension this. So we will say 2.5 plus 6 times this. I don't know why it's not letting me do it, but if not, let's use the calculator. Okay. So let me use a manual calculator because the computer is against me today. So so 2.5 plus 6, 0.4, 6, 8, 5. Okay, so this should be a distance. Let me see if I remove the parentheses. Oh yeah, what's that? Perfect. Now let's do another one. This and this coincident, and this parallel. Perfect. And this must be separated 0.5 inches. Of course, you can change it. This is just the design that I did previously, and right now maybe you may be thinking that I don't know what he's doing, but you will see at the end. This is the only step that is difficult to explain, especially for me. So just be patient, and I will be finished. So let's do another one that this dimension. It's also 0.5. This and this coincident. Perfect. So now what we want to do is mirror these 2 lines with respect to this. So we come to mirror entities and mirror these 2 lines with respect to this. Okay. And now we're gonna cut. So it's gonna trim entities. I will be cutting, just look at the final shape and try to get the same final shape. So I'm gonna be cutting. Yes. So we want to remove this shape because now when we come here and extrude here for, let me remember, 4 inches, you see that now we have made a cut so that here the pedal can come, and here we can put the screw that will secure the pedal in this position here. Okay, that was a very difficult part to explain, I'm sorry, but just look at this shape and try to do something similar. Of course, you don't have to do the same trash can, you can design it your own, so as you prefer. Okay, so now what we're going to do is we're going to position where this point and this point will be in the trash can. So we're going to come to the front plane and we're going to open a sketch. We're not going to do anything with this sketch. We're only going to position the points that we are interested in. So we make this big because let's go normal to this sketch. Perfect. And now we're going to put 2 random points, one here, another one here, and now we're going to put them into the proper position. So if you remember, we extruded it for 38 inches, sorry. We want this distance to be 37. So what we're going to do is from here to here, it will be 1 inch. And from here to here will be 37. Okay, remember also that between here and here, we want a distance of 21. And we can also say that the distance, because now they are really close, right? This point here, we may want it a little bit. Of course, you can personalize it. So just put the numbers you want. It's just that for me, I know the values that work, so I'm trying to use the same. So let's put 20. And now both points are perfectly defined. Perfect. So let's exit the sketch. And now we have these points for whenever we need them. Okay. Let me see one thing. Okay. So now what we're going to design is the cover. So let's just save it. Sorry, I have the control. Okay. Save it. And let's open a new part, which will be the cover. save it as the cover. Perfect. And if you remember, this diameter was 30, right? So we're going to do the same for the cover. So we go to the cover. And in the top plane, we're going to design a circle of 30 inches. Let me put this in inches again. Perfect. And now we're going to extrude it for instance, 3 inches. Okay, so that will be our cover. Now we have to modify it a little. So the first thing we're going to do is we're going to add some extrusion here that will go up to this point here. So what we're going to do is we're going to work in this plane. We're going to open a sketch. Well, we're going to extrude it. Let's work normal to this plane. Now let's do a center line because we're going to use the symmetry. Okay. In fact, let me delete this because the point we know that it has a distance of 20, right? Yes. So what we're going to do is go from here to here, and we're going to say that this is, for instance, 2.5 plus 4 times the distance of the bushing. You have to believe me, but if not, again, when I designed it for the first time, I used 2.5, and then after doing the assembly and realizing that I needed the bushings, I need to add this distance 4 times. So don't worry, if you want to just do it by yourself and use the 2.5, it's okay, and then you can modify it afterwards, so don't worry. Okay, so perfect. Now let's gonna do the symmetry. Wanna be symmetric with respect to this axis. Okay. Let's also this, and now let's implement this. This. Okay, so I want to extrude this. And we want to extrude it the other way. And to the surface, to this surface. Perfect. Okay. So now we have this, and we know that here we will need the last point of the mechanism. So we're going to design it. So we're going to open a sketch here. And we're going to make a circle here of 1.5. Okay. And let's extrude it the other way to the next surface, which will be this one. Okay. Perfect. Now we want to make a hole. So remember here, we will need a bushing. So we go back to the bushing. What is it? Here. And we measure this diameter. So the diameter is this one. So we copy it. Now we go back to the cover. we select this face because we will gonna cut a hole here, which will be centered here, perfect, and we will have a diameter of the bushing. Just copy it. It's pretty small, but it's what it is. So it's not that it's small, it's that the trash can is really big. So let's close it, and we want to cut up to the surface from the other side. Perfect. Great. Nice. So now we have to build the difference part that will do the mechanism. So we need the information from here. I can tell you that this solution is similar than this one. Not really similar, but it has a point. So as you can see, if this is the trash can, this angle here is constant. So whenever it moves, this angle doesn't vary. So if this is the cover of the trash can, we can consider this as an extension of the trash can. So what we're going to do is, so and how we determine if this is the position 2137, this is the position 21.34, 29.40. So we can, if we set it to 0 by subtracting this distance, then we can know where this point should be. The same for this point here. So if the last point is at 2137 and the previous point is at 22.42 and 29.23, then we can know the position of this. So what we're going to do is open a sketch in the front, in the middle, so in the front plane. So we're gonna open a sketch here, and we're gonna extrude. So we want 2 points. We want a point that is here. Perfect. Let me work in a normal plane. Now, okay. And another point, we will put it here, for instance. Nice. And what will be the distance from here to here? If we go back, so this will be a distance of 22.42 minus 21, so 1.42. Okay. And this distance here, which will be 37 minus 29.23. So 7.77. Perfect. So we need an extension from here to here. So here we know this and this must be equal, and we can also make this equal. And now we can draw a line from here to here. And here, this line must be tangent. Now let's going to convert entities. So I want a line that comes here. Another line. And now we want this surface to be extruded, right? So we need to trim this, and this, and this. Nice. Right? Okay. So we're going to exit this sketch, and we're going to extrude 0.5 inches in both directions. I don't know if, yeah. Because for all the bars, I will want the thickness to be 1 inch. Perfect. And we have our color. I hope that I am doing all the calculations correctly, because if not, at the end, it won't work, but we'll see. So let me save this. Now we can start to build the assembly. So we go here. And we insert the base. And we insert the cover. And we save it as homework 6. So right now, what we are missing, just realize, it's some part here in the trash can that can attach, sorry, to this, right? So we're gonna open the trash can. And we're gonna build these parts. So we will need a front plane, but that it's not in the middle. That it's in the place that can be attached to this part here. So remember, this distance was 2.5 inches plus 4 bushings. Then we will need two more bushings. So we will finally need a distance from the middle to this point of 2.5 inches plus 6 bushings. So we will need to define a plane. So we go to here, reference geometry, and define a plane from here, but that is a distance of 2.5 plus, let's go back to the bushing. I need to define it first. So let's put 2.5 inches and then modify it. So let's go back to the bushing. Let's copy distance. And let's edit this plane, because this has to be 2.5 plus 6 times this distance. Now, perfect. So we're gonna work normal to this plane. Oh, no. So we're gonna go normal to this plane. Now this. And we're gonna extrude. So we need here yes. So we need this distance. We know that this will be 1.5. We're consistent with everything that we've been doing. And the other will be the distance, the diameter of the bushing. So here, and this dimension. Perfect. So now I want a line that goes from here to the center. I just pick this so that the sketch is defined. And then from here to here. Perfect. And I will define a distance. What did I? Of 1.3, for instance. You can pick whatever you want, as always. Perfect. And now let's trim some entities because we don't want this line or this line. Perfect. And we are going to extrude it outside. So let's exit the sketch. And let's extrude it for 1 inch. It's giving me some problems, so let's try to discover which is which. Oh, there is here a line that shouldn't be, so let's trim this. Now, yes, now it is working. I don't know why this distance has been lost. Perfect. So now we don't have, I think it could work, so let's try again. But let's use it to extrude. And we want 1 inch, we said. Perfect. So we don't need this plane anymore, so we can hide it. And as you can see, it's the front plane. We have set a distance of 2.5 plus the 6 bushings, this support that will be attached to the cover. Now we want to make another one in the other side of this plane, right? So what we can use is the linear pattern, the mirror entities. So with respect to this plane, if it is not selected by default, you can select it. So we want to mirror this last thing we've done. You can see that it appears. So we accept it, and that's it. We have it. So again, we save it. And now we can go back to the assembly. Perfect. And now we can start given relationships. So what we're going to do is, okay, so I want, remember this relationship, which was, yeah, the width. So we select one side, another side, and then the two faces in which this will be in between. Perfect. And now this and this must be concentric. It looks like I made some mistake with the distance, well, with the dimensions, but at least we can see that this is working, right? Okay. So let me see what I have done wrong. Because if I did this properly, in between this and this, I will have a space to put two bushings, one for this part and another for this part, and the same here, right? So of course I have done something wrong. Let's open the trash can first, or maybe this one. Let's see what has happened here. So if there is an error, it should be in this plane. So let's see how I design it. Okay, so it shouldn't be 2.5, right? It should be 2.5 plus the distance from the bushing. So here is the error. So it was, let's go to the bushing. Let's copy this distance again. Let's go back. And let's see why. So it's 2.5 plus 6 times this distance. Yes. Yes. Okay. So let's save it. I don't know if it has been actualized, so let me, yes. And now let's go back to the assembly. And now it looks like it is correct, right? Perfect. We can even attach the bushings. So we can insert components, insert one, two, three, four. So one will go here, right? Perfect. And the same with the other ones. maybe it would have been better to first attach the bushings and then the other. So now this and this face. Perfect. Then this face, coincident, this, and this. Perfect. Now you can see that we have one bushing, two bushings, yes, and F. Well, and we will be able to see very soon if there are collisions or not. So remember this face, coincident. What did it go? Oh, I am not making it. Okay. So this and this, perfect, coincident. Now this and this, concentric. This face, not the face, and this face, coincident, right? And this, concentric. Perfect. And finally, this face. This face, incident. Sorry. Perfect. It looks like it is correct, but just to be sure, let's go to evaluate and detect interferences and put calculate and no interferences. Of course, if there were interference, for instance, in this case, if we ask to detect interferences, we will have all the surface here that it's making an interference. So, but that's not the case, fortunately. So far, so good. Now there is a very cool relationship, which is the maximum and minimum angle. So if you remember, we want this to be 180 and this to be 80, right? So, I mean, if this is the 0, this is 100. So we can go here and say, okay, mate, go to advanced mates and select this one. So we select this and this, and we say, okay, the minimum is 0, and the maximum is 100. And now if you see, I can only move up to here and up to here. We can see that we will have to do some modifications here to prevent this collision with the movement. But of course, we also have to empty the trash can, so everything one step at a time. So, okay, what's next? What we can design now, it's the next part, which will be the intermediate one. So let's go back to the results. And we know that the distance will be this value minus this value, and this value minus this value, right? So let's go this, it will be a moment. So need to remember to save everything. Okay, so let's open a new part. And let's extrude something in the front plane. So we're gonna do a circle and a circle. Both of them will be equal. And they will be dimensions 1.5. And of course, I forgot to change to inches. So I need to come here and change to inches. Perfect. So let's go back to the sketch. Okay, I want the dimensions from here to here to be this, well, this minus this, right? So let's use the calculator. 29.28 minus 22.42. Okay, 6.86. And this other dimension, which will be this subtraction, so 29.23 minus 20.75, 8.48. Great. Everything is completely designed, so now we just make two lines, another line. I want this line to be tangent. I want this and this to be tangent. Okay, there is some relationship. It's breaking everything, so let's see what's happening. Let's select this. And we can see that there are two tangents. So let's select everything. Okay. So I have a coincidence here, which I don't want yet. So let's select it also. Okay. And a vertical, which I don't want also. And that was the problem. So don't worry when everything looks like your sketch is really wrong because it's all red. Just by solving a few relationships, you can get it back to normal. So we want this and this, tangent, this and this, tangent. And these things happen because sometimes, for instance, if I want to design a line and I start from here, sometimes you see that this dotted line appears. Then the line will be designed with a relationship. You don't have to design it. For instance, if I start from this point and I end the line here, this will understand that this point is together. So you don't have to say, okay, so this point from this line and this point from this line, they are coincident. No, if you start from this point, they will understand that it's coincident. And the same happens, for instance, if you start from here. I don't know when exactly it happens, but sometimes if it was a dashed line between here and here, it could understand that these points and this point and this point must be horizontal. And when you modify this, then it will modify also this. So be careful, especially when you want to make tangents and everything, that when you design, you don't start with any dashed line if you don't want. So let's get rid of this. And we want finally this and this to be tangent. Now we can trim the ends. And we can add the poles. And we will say this. Sorry. We will say this and this to be equal. And the distance will be the diameter of the bushing. So again, we have to go back to here and measure, copy this diameter. Go back here. Okay. And measure this. Perfect. As you can see, as we have said that this and this must be equal, we don't have to define the dimensions of this hole. So we can exit finally, and we select, and we press extrude, and with all the other bars, 1 inch, right? And that will be it. So we save it as our bar. And now what we can do is we can go back to the assembly. Can close this. We go back to the assembly and we insert two bushings. And put here this and this have to be coincidence, and this concentric. Same for the other side, this and this coincident, this concentric. Perfect. Now we can insert the bar and the other bar and the corresponding bushings. So one for this side, one for this side, one for this side, and one for this side. Perfect. So we go here and we say, okay, so this coincident, this concentric, this and this coincident, this and this concentric, this and this. Perfect. And finally, this with this has to be coincident, and this and this concentric. Same with this. Perfect. So now we only need to design the last part, which we have an L shape, right? So there will be the pedal, and this will be where the mechanism, the 4-bar mechanism, will start. So the 4-bar mechanism will go from here to here and to here. Okay, so if we from here to here, so this will be the first bar. will be the second bar. This will be the third bar, and the fourth bar, which will join the two bases. And then the pedal will have a fixed angle with this first bar, okay? So we're gonna design it. First of all, which I forgot, we can make this hole pretty easily. So the hole will have the dimension of the bushing, so yeah, so this dimension. So we measure this, we copy it. Now let's open the trash can. I don't know if I forgot something with them. Yeah, well, all good. Okay, so we're gonna open a sketch here to make a hole. Okay, so first of all, we need to, this point is outside the plane that we're working, which is this one. So what we're going to do is convert entities. And now this point has come to the plane that we are working. So we're going to design here a hole, and its dimension will be the one that we choose. Perfect. And we will cut this from here up to the other surface. Why it is better to use surface and not distances to make holes? Because if for any reasons we get some error in our calculations of the distances and we need to modify this particular distance from this wall to this other wall, then if you have defined this hole up to the next surface, this distance of the hole will be actualized with the distance from here. But if you set a constant distance to here to the other side and you make it bigger, then the hole that you made will not arrive to the other side. So that's important. I mean, it's just some tricks that you learn as you use SolidWorks. So now I think we don't need this point anymore, so we can hide it. Perfect. And now we're going to design the pedal. So let me see if I have everything saved. I need to save this on the base. Okay. So let me save everything. This one. Perfect. And let's open the last part that we're going to build, which will be the pedal. So save as pedal. I assume it's pedal when you call in English. Hopefully I am not saying anything stupid. Okay, so how I define the pedal? Yeah, so we're gonna use the top plane, no, the front plane, yes. And we're gonna extrude something. So a line from here to here, and a line from here to here. Okay, so we are free to so this will be the first bar and this will be the length of the pedal. The length of the pedal, we can choose whichever we want. I forgot again to change this, so let's. So the length of the pedal, we can define it however we want. So let's set it to, for instance, 18 inches. Okay, and this we have to use these dimensions, right? Which is the distance from the origin to the first bar. So it's 29.28. Perfect. Let's go back here. Cool. I don't know what has happened, so let's go back. So it was 29.28. 29.28, right? 29.28, 20.70. Okay. So this distance will be the, this position of the first bar will be when the bar is at rest. So when the mechanism is at rest. So it will be the position where it's the first input angle. So as you can see, the first input angle is this one, right? So when the pedal is at 160.07 degrees from the x-axis, then the position of the first bar will be this one, the one that we have just drawn. So this angle has to be this one. So we go back to the SolidWorks, and this angle has to be this one. Perfect. And now everything is defined, and everything is happy, except this. This is not defined. So just to define everything, this vertical. Perfect. Great. So now we go here and say, okay, so this, another one, this will be 1.5, right? And this and this will be equal. Perfect. So now we need to make some lines. So this and this to be tangent, and this also have to be, sorry, this and this also have to be tangent. Now this and this to be parallel, and this also have to be parallel. Great. And the same for the other one. So this and this tangent, the same for this one. Perfect. So let's trim that we don't need, which is this one, this one, this one, and this one, this one, this one, and this one. And what we can do also, define this for construction, and the other one for construction. We can also make it a little bit more elegant by adding here not letting me, I don't know why, but well, we will do it later then. So now let's make here and here 2 holes, which will be equal. Oh no, sorry, here I don't need the hole, because here the pedal, it will be where the pedal will come. So, sorry. So we need a line here. We need to remove this line here. Now if I can remove it, this. Yes. And this for construction. Yes. And this distance, which will be, sorry, this diameter, which will be equal to this one. Let's close it. Okay. And now let's see what's the problem here. Because if we try to exit and let's try to extrude this, it won't let us. Or yes, it lets. Okay, great. Let's see if we say 1 inch. Okay, I didn't say anything, but it won't be 1 inch because we will need it to be 2.5 plus 6 times, sorry, 4 times, yes, 4 times the distance from the bushing. So let's go back to the bushing. I think this is the last time we have to do it, fortunately. Close it. This has to be plus 4 times this distance. Yes. Okay, oops, sorry. And the same for the other side. So copy this, direction 2, the same. Perfect. I don't know why didn't make the hole, but doesn't matter. We're gonna do it right now. So what we can do is make a fillet here. 3. Also here. Yeah. Much nicer, right? And then here, we will make a cut here. Let's work here. And of course, we need this distance again. This will be to the other side, so up to surface this side. Perfect. And now we can also add this part here. It's the shape of the pedal, so let's do something. So let me draw a center line from here to the middle. Okay. And now let me sketch square. And you, as always, you can decide the dimensions, but I will use the ones that I already had. This will be 4, and this will be 2.5. Maybe 4.5. Yeah, should be better. So let's mirror these entities respect to the center, to this axis. And now let's exit this, and let's extrude this to the other side though. Up to the surface, so up to here. Perfect, pretty good, isn't it? Nice. And finally, we need to cut here because here will come the first 2 bars. So let me cut. Yes. So again, let's make a center line from here to the center. Okay. So let's make this distance 4. Then this distance, as always, will be 1 because this will be what will be attached to the second bar. Okay. And then this distance, let's make it 5. Perfect. So if we go normal to the sketch, we can see that we go a little bit out, but it's okay. In fact, that's what we need. So we need to cut all this because the next bar will be inside here. So let's mirror entities. So let's mirror this, this, and this with respect to the center. This, this, and this with respect to the center. Oh no. And this must be horizontal. Yes. Okay, let's exit the sketch. And let's cut up to the surface. This one. Perfect. And we have the pedal. Oh, sorry, we need here the hole also. So let's open the sketch. Well, the hole is in the origin of coordinates, so we can make it later. So we can make it now. Let's open a plane. Sorry, let's open a sketch here to make a cut. So and we're gonna make a hole. The origin with the dimensions. No, we don't have to do it. We just press this and this, and they have to be equal. Perfect. And now we zip and make the cut. Up to the surface here. Okay, so you can see that we have lost a lot of material when doing the fillet. So what we can do is we go here, we open it, and we say, okay, I want to do multi-radius. So this one, instead of being 3, it will be 1. Let's try it. Much better. So now we have more material between this here and here, so it's better. Okay, so now we can save it. Let's go back to here and insert it. So insert, no, sorry, I am a little bit tired. I don't know what I'm doing anymore. So let's browse the pedal. Now let's open the bushings also because it will be faster. So let's mount the bushings. So insert components, bushings. We need one here. We need another one here. Okay. Cool. So this and this. Perfect. Let's insert the bushings for this part also. Now we'll move everything here. Now I think it will move again. So this and this. Perfect. Now this. This. The other side. This. And this. Perfect. Now we're missing this one. And this one. Perfect. Now we have to come here and say that this must be concentric with this one. Okay. And now let's see if it works. I don't know if it will work at right now, because it can be either this way or the other way. So let's see if it works. Yeah, it looks like the movement is perfect, right? So we have almost finished. Now we only have to make some modifications in the can so that there are no collisions. Oh, and I forgot also the last bushings here. So, oh, let me save it. Yeah, for anything that happens. Everything is safe, right? Yes. Okay. This will be tough, but we'll do it. So we need how many bushings? 6 more. My God. Okay, so let's try to do it. So bushing number 1, number 2, number 3, okay. So let's start with the easiest. Let's move them down, not fully complicated. So one thing we can do is we can say I want to disappear for a moment, so I'm gonna hide it. Much easier. So we're gonna make this the other way. With this, and with this. No. This. 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 this, and this. Perfect. Now, this face and this face and this and this. This face, this one, and now we want back the part that we have hidden. Okay. Now, this. This. We need this to be instead of being 0.5 inches, we need 1 inch because now the bushings are gonna collide, if you can see. But we will modify it later, don't worry. You see, now they are colliding. Hopefully it's not really hard to do it. We'll see. So this and this. Perfect. So let's open this. Let's try to modify this sketch. Hopefully it doesn't. Let's see if we say here 1. Okay. Do the same here. So no big deal. Perfect. So if we go back to the assembly, we save it just in case. Working properly. And if we see, if we calculate, if we ask to see if there are collisions, there will be 1 collision, 2 collisions, and that will be it, hopefully. So let's see. Yeah. So 1, and the other one, which is this one. Perfect. So we need to make space for this, right? No problem. So first of all, we can start doing a space for this problem here, right? Okay. So what we'll do is, we're not gonna be very rigorous. We just gonna say, okay, so what's the distance here? Let's measure some distance from here to here. What's the distance from here to here approximately? Okay, so it's 3.5, right? 3.5 will be a good. We will be safe if we make this, right? Okay, so we open this. We go here, and we're gonna make a cut here. So let's go here to here, 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 and back here. Okay. And I don't know the distance. Let's let's just say a distance of 6. Let's see if that's enough. If not, we'll modify it, so don't worry. And let's go down 5 inches. Let's try. So it looks good. Let's see if our objective is achieved or not. Okay, so far so good. If we close it, we see that we need to go deeper. So instead of 5, let's try 8. Modify it, and let's try with 8. So, I mean, now the word that we are left is this, just trying to make that there are no collisions here. Yes. Now let's try if there is some problem. Not. Oops. Here we are safe. And go. Yeah, we're totally safe. If we close it, we're also safe. So that's great, right? Perfect. Now, we can press this button to make an internal view of the object. So we can section view, and let's go to the middle. Let's try to go to the middle. Okay, it's here, and let's press accept. Okay, if we press this, we're gonna go out of the mode. Okay, it's just because this way we get a better view of this. So as you can see now, there is no collision. But what we need to do is clear some space for this bar, right? So what we can do is make a line from here to here, for instance, and remove all this. Okay, so from here to here. We could also make a line from here to here, but it will be this space here will be really weird. So yeah, what we're going to do is just draw a line from here to here. That will be it. Because if this is a trash can, we cannot use this, right? Of course, the bug will go here. Of course, this is not an optimal trash can because we are losing a lot of space, but you understand, right? So let's make a line from here to here. So let's go back here. And now we will work in the front plane. And we are going to do a cut. Okay. Perfect. So I want to start from here, go to here, then go somewhere here, somewhere here, somewhere here. Okay. And if you want to define that everything is defined, just smart dimensions, and let's say that this is 5. Now everything is in black, really nice. Okay, so now we can also do this, which will be for the pedal. And no, sorry. Let's make an angle 20. I don't want this line. And this to be 15. Nice. Okay. Looks nice. It's just I put 20 degrees because 180 minus 60, it's 20. So it's a tentative. We can modify it later. So let's exit the sketch. And we will use this sketch to cut a hole. Okay, it's not letting me because, let's see. So let's redefine it. Okay. Let's use it, this line for construction, and this line also for construction. Now let's define a point, this line, that is 0.5 inches from here. And now, yes, let's line from here to here, from here. Now we have to, because if you define two surfaces from a different point, then SolidWorks has problem to identify which, if you want to use only one or two, so it's better not use the same point. Of course, if you really need this point to be here, you can do this twice. So make first this cut and then the other cut. But in our case, we don't need to do that. So now, yes, we make a cut and we want to go to the surface, this one. Perfect. And if we need the same for the other side, right? So we can edit this cut and say, okay, the other direction, also, let's go to the other surface. Let's go back to the assembly. Let's see if that works. Oh, what happened? Be careful not to, I mean, this is blocked, but if you go more the way, then some relationship will be broken. I don't know why. So let's try to limit the movement from here to here. So we have a relationship that limits our movement from 0 to 160 to 100, sorry, the output, but don't force it more, just in case. You can also define this move, instead of defining this limit, define this limit, which is smaller, so whatever you prefer. So let's get out of here. We can modify this a little bit more if you want, but I think that it's not needed for this project. Of course, if we wanted to do a proper trash can, we will need a much better one, because with this trash can we only have this space, and I will also add some security distance here. But in that case, I think it's not that important. So we'll close it. And now we're only missing one operation because this trash can is not empty. So we go back to the can. We don't need this anymore. Go back here. Select the surface and make a shell of 0.5 inches, for instance. it will give an error. So what this will do is it will empty all the solid, leaving a wall of 0.5 inches. It will give me an error because this surface here, this part here cannot be emptied, leaving a wall of 0.5 inches. But by default, it will try to do it, and this part we won't be able to do, and we'll leave it as it is, which is what we want. So we press enter. Yes. And that's it. We have our trash can. Now we can color it if you want, because we don't need to, but we need to color the different parts of the mechanism. So we can also color the trash can. So let's make it yellow, maybe. Yellow, for instance. Save it, close it. Great. Now this part, we need it to be green, right? So we go here, appearance. Great. Close it. The intermediate bars, they have to be blue. And this last one has to be red. Perfect. Save it. Close it. And now we have, save it just in case. Save it because in case you break the relationship because you force it too much, then you can go back and to the original. If not, you can always go to the mates. Let's go to the limit angle, delete it, put the mechanism as it should be, the position that it should be, and then define the limit angle again. Okay, so that will be it. The last thing we have to do is do the animation of the mechanism working. So I recommend that you save it. And now that make another document that it save animation. Save as a copy and continue, because if not, it will just change the name. So save it. Now we have the mechanism and the animation. So we open the animation. Why did I do it? Because we have two exact mechanisms. One is an animation and the other is just this. So the reason why I did it, it's because to do the animation, I will have to get rid of the limit angle. Because for the animations, we want this to be oscillating, right? So if you put a motor to turn this, and this movement has a limitation, SolidWorks doesn't know what to do it. So it will say error, I don't know, and the video will never work. So in order to do a video, you need to get rid of this. So now that we are in the animation, we go here and delete this. Now you can see that we can break it. So, sorry, before breaking it, before breaking it, yeah, now it's limit again. Let's put into the maximum position, okay? either the maximum or the lower, because with the motor, we will tell the mechanism to move from here to here, and we will need to specify how much we want it to move. So if we say 100 and we start from an intermediate 100 degrees, and we start from an intermediate position, that it will go from here to here, and it will collide with the cam. So we want it to be in the extreme position. And now when it is in the extreme position, we delete this relationship. Yes. Now we go to motor study, and we add a motor. We will add it here, for instance, because this red part will be rotating, right? So we add it here. This direction is correct. We want this to be oscillating 100 degrees and 0.2 Hertz, for instance. So one oscillation every 5 seconds. So we say okay, and let's, 15 seconds. Let's see if it works or not. It looks like it's working, right? And now, of course, you come back here and you can do all the orientation things. So you disable the view key. You say, okay, when it starts, I want to be here. Then at 4 seconds, I want to be in this position. Then at 9 seconds, I want to zoom to study the mechanism, and I want to start here. Copy, paste for 1 second. And then here, I want to be down, so we can see the mechanism from here, for instance. And I will go back to this view, maybe from the other side. For instance, and let's see how it works. It was pretty cool, right? Okay, and that will be it. Oh, now that I think, I forgot the axle screws, but you just have to put one on each hole just for aesthetics, and that will be it. But I won't do it because now it will be making the animation again and everything, and it will be for aesthetics. So you do it, right? So you remember that you have these axle screws, and you put them in each of the holes. So I leave it here. Thank you. Remember to save. And remember also to do the video. You need this save animation button. You go here, you select AVI or MP4, the aspect ratio that you want, and also the number of frames that you want per second. You make save, you select save, and that will be it. The homework is done. Thank you so much for listening. I apologize for some lapses that I had at some point, and see you next time. Bye.